This is 11.1a of geometry. So we're going to start talking about volume and surface area. So we're going to start working with 3D shapes. We're going to talk about polyhedrons. And a polyhedron is a three-dimensional figure where each, what you would call sides, are polygons. Okay, so this is a polyhedron because each side is a quadrilateral. Okay, there's three terms that we use when we're talking about polyhedrons. A face, okay, this is a face across that front side. This is a face on the top. Okay, an edge, that's where two faces meet up. So this is an edge right here. This is an edge right here. All the way back here, this is an edge. And lastly, vertices are what you would call a corner. This is a vertex. These are vertices if we're talking plural. So if we look at this polyhedron, we're going to list the vertices, edges, and faces. Okay. So first, let's start with vertices. So that's what we would call corners in regular non-math terms. So our vertices U, R, S, T, W, and V. And then edges, I'm going to switch colors so that I can go through and mark these. Okay. So there's an edge here, UV. And you need to put a line over it because it's a line segment. RU, RS, UT, ST, TW, SW, and VW. And lastly, RV. I've covered every line on there, so I got all of them. And lastly, I need to list all of the faces. And we're going to list those with what kind of shapes they are. So, in front, we have a triangle here. Right, this side is a triangle. So we've got triangle RUV. In the back, we got this triangle, triangle STW. And then we've got some quadrilaterals. So I'm going to list all of those. So let me switch colors for you. I've got that left one. That's RSTU. Got my bottom one there. UTWV. And then I've got this top diagonal one, which is RSWV. Okay, so there is a formula about faces, vertices, and edges. And this is called Euler's formula, not Euler's. I know that's what it looks like it's spelled, but it's Euler's formula. Okay, and it's given here. If we add the faces and the vertices, that's the same thing as the number of edges plus 2. Okay, so let's put that to use. So we're given 2 of the numbers. We need to figure out the third one. So remember our equation, F plus V equals E plus 2. So we don't know what our number of faces is, so I'm going to leave that the F. We know that we have 20 vertices. We've got 30 edges. So this is F plus 20 equals 32. And if I subtract 20 from both sides, I get that F is equal to 12. So there are 12 faces on that shape. Over here I know the number of faces and I know my number of vertices, but I don't know the number of edges. 32 is equal to E plus 2. and I get 30 edges. So there's one other equation, formula, and that's this one right here, and this is Euler's formula for 2 dimensions, so when we're working with a net. Okay? So first, we're going to look at this picture. We're going to figure out the number of vertices, faces, and edges, and plug that into Euler's formula, okay? So, number of faces, I've got 1, 2, 3, 4, 5. Vertices, I got 1, 2, 3, 4, 5, 6, 7, 8. And edges, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I plug that in, I get 5 plus 8 is equal to 12 plus 2. That gives me that 13 is equal to 14. So I screwed something up there, right? It should work. If I count my faces, 1, 2, 3, 4, 5, 6. Oh, I had 6 faces. This should be a 6. This should be a 6. And that makes it 14. It should always come out true for a polyhedron. Now what I'm going to do is I'm going to draw the net for this shape. Okay, so I'm going to start with drawing the bottom. And if I draw the right side, that's another quadrilateral. Draw the left side, that's another quadrilateral. Both the front and the back are trapezoids. And then my top is another quadrilateral. That could either go here, 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 or here. Since I've got more room on the side, I'll stick it on the side. It's a smaller one. So there's my net. Now I'm going to figure out the number of faces, vertices, and edges for this net. Okay, I'm going to get different numbers than I did before, but it's going to work if I use the formula for the 2D one. Okay, so first faces. Got 1, 2, 3, 4, 5, 6. That number should be the same. Vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's a lot more vertices, right? Because they're not connected. And last, edges. Let me switch colors for that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So now if I plug it into this equation here, 6 plus 14 is equal to 19 plus 1. And I know I did that right because the formula works. And there's your homework.